Thanks again, everyone, for coming out today. This is the first class that I've been teaching here at AU, my second time attending here. And I attended last year when I believe 5-axis toolpaths were just released at AU in Fusion 360. It was also about a month after I got my first 5-axis machine, so I was pretty excited about that. But one of the big reasons I got a 5-axis machine was primarily to really just cut my amount of setups down. So actually I spoke to Lawrence, I met him last year, and we spoke quite a bit, and we thought if we both attend here next year, this year, that we would decide to maybe do a joint class together. And then Dr. Phil, I don't know how many of you guys know him by Instagram, he also started using Fusion last year. Yeah, and has been doing quite a bit of 5-axis work as well on his new 5-axis machine as well. So we told him to join in with us and kind of share some of our experiences using Fusion 360 and 5-axis. So does anyone here use 5-axis machines right now, or? Okay, so there's quite a few around here. And Fusion 360, or, yeah, pretty much Fusion 360, okay, right on, awesome. So there's a few of you that know it, some of you are kind of green or new towards it. Everyone's machinist here, or almost everyone? Yeah, half, sort of, okay. Yeah, that's probably the only thing you probably need to fear about, I think, going into 5-axis. So just a real quick overview of the class. We'll do a real quick background on all of us. I'm going to talk primarily just about the way I switched from 3-axis to 5-axis, and then Phil's going to go into a little bit about work holding and multi-part holding, and then Lawrence will finish up with some 5-axis simultaneous toolpaths, and then if we have some time at the end, we'll do some Q&A from there. I run a one-man job shop. My dad started the shop back in 2001, primarily just a 3-axis shop. My dad's first machine was a Haas VF7, which you see in the background there. That still runs to this day and is still my workhorse to this day. I worked about 10 years with my dad. Never went to school, learned everything from him, was pretty much the shop rat. I didn't do a lick of programming. And then I decided to take a bit of a leave from the industry. I just found the shop wasn't progressing where I wanted it to go, so I went into a completely different industry. And then after about 5 years, I came back, ended up taking over ownership of the shop, and then realized I had to learn how to program these machines. So that's where Fusion 360 came in for me. I started learning that in about 2014, and then about a year and a half later, while running the shop, my biggest thing is we're primarily a low-quantity prototype shop. The amount of multi-operation parts that we were doing was just killing my machine time. I just found I was just setting up and setting up and setting up, and just being able to actually get my machines running was taking more effort. So in early 2016, I decided to make a pretty big jump up, and I bought the EMG monoblock, and that came in, like I said, about just over a year ago. And that's kind of where I am kind of today. So I've had the machine just over a year. It's definitely opened up the doors to a lot of different work that I would never see, and also just really been able to optimize the type of work that I've been doing in the past. So that's been a bit of a nutshell. And Phil, if you want.
All right, most of you probably know who I am. I mean, it's pretty obvious to most that I'm the guy on the forum that actually is there more probably than doing real stuff at the shop, because the moment I've got time, I'm just on the forum bitching around on all 3 HSM products, so HSM Works, Inventor HSM, and Fusion. And yeah, I've been here last year, and now we're trying to teach some classes. I did a robot CC automation with robots class just in front of this. So that's kind of me. We have a small job shop in the Netherlands, so pretty far away from here, pretty big trip. But we'll try to make parts 5-axis on our multitasking machine as well. So that's how I got into 5-axis stuff. And that's why I'm here.
Thank you.
We build very high-end aftermarket parts for Harley-Davidsons, and we bought our first 5-axis because everyone in the bike game has a 3-axis, maybe a 4-axis, so designs are all the same. So to really push our brand ahead of everyone, we had to make really fancy designs, and to make those designs, we went 5-axis, and that just, it throws you above everyone. But mostly, as you can see, we bought it because it makes really sweet Instagram posts. And that's about it's all about the followers. And I just use Fusion 360 for everything, for all the designs, all the 5-axis work, everything. That's about it.
You do everything from design?
Yeah, I personally in our company do all the design, programming, and manufacturing. So I have very long hours.
Awesome.
Yeah,
Great, thank you. Let's 9 minutes later. Yes? Where were you stationed? Vancouver, British Columbia. Yeah. So I think one thing I try to kind of let people know who are kind of new to the 5-axis game is I guess when you go to trade shows, they're a bit of a fault for when you go there, every single 5-axis machine you see is moving in every single direction possible to make a hole. And sometimes I don't understand why they don't just drill the hole, but they've just got to get the table moving in every different direction. So a lot of times when you do go and first see that, it is a bit daunting. I know when I first kind of saw it, but then the more and more I spoke to people, the more they seem to tell me that you're generally not making the table move that much. It's primarily a positional game, and 5-10% off maybe the work requires a little bit of simultaneous work. So that's probably the biggest thing I think when people talk about, if you're in 5-axis, people are worried about all of that. For me, the biggest thing again about 3+2, and one of the reasons you want to do it is really to lower the number of setups, saving time, and limiting the operator's interaction with the parts. In my shop, it's just myself, but I have some jobs that require sometimes 8 different setups, and if I'm doing that on my traditional 3-axis machines, which I never had an actual running shop probe on them, you're picking up the part 6 times. And granted, you could probe a part perfectly every single time. If you forget to lock that vise on the 7th setup and your part moves, you're starting from kind of scratch again. So the nice thing for me with a 5-axis machine is your part's kind of locked in. You can generally do most of the work kind of at once. I've got a couple of quick little demo parts I'll pass around. This one here was done with the dovetail. I don't know if some people consider a dovetail a setup or not. I don't. But this part was done in 2 setups, which would traditionally be 6 setups. I'll pass it around. That part of there took, once it was running in production, I believe about an hour with 38 tools to do that particular job. It had pretty tight tolerances. I don't know exactly what it was used for, but it's for the medical industry. I have a feeling it's used in a dialysis machine. But again, a lot of the work I do, I pretty much send it out and never see it again. So that's just one of the parts. I believe I was off by a couple thou, so I kept it in-house for that reason alone. Not including the dovetail, 2 setups. So there's one side on there with 1 hole that was done on the last operation just to face the dovetail off and drill the last hole, but everything else was done in 1 setup. If you're wondering how to 3+2 in Fusion, it's actually quite easy. In almost every geometry tab, there's an option for tool orientation, and it's quite simple as just kind of clicking on a face and setting your Z from there. The machine control takes care of the orientation offset, and it's really kind of hard to explain. I never quite understood that when I was first getting the machine. I'm thinking, well, the table flips to 90 degrees, the Z height's changing. How is that all kind of working out? Lawrence, you kind of explained it a little bit, kind of yesterday when we were talking about the best way to explain that. Kind of when you're picking your Z offset and rotating the table, and then the control takes care of it all.
Yeah, of course, it's most controls now just have the dynamic work offset or something similar. I mean, for the high-end controls, it's called cycle 19, and for Phonics, it's G68.2. And I mean, like that, most controls you buy nowadays, you can or buy the option or it's built in. Most machines you actually buy that are 5-axis at least have that version. Might not all might have actually TCP, the tool center point control for 5-axis, but that one's in most any machine actually now.
What's going on here? So orientation is all standard in Ultimate? That's a good, yeah, it's not non-standard, right? Yeah, it's just an Ultimate now. A lot of issues I've sometimes had up with is trying to get into odd angles. I'm going to go to Fusion here quickly and just show a basic part here. And to give an example, and let's see if I can get this going here. I'm working kind of backwards here. So just to, I knew this was going to be, Saunders, my Space Mouse was rolled upside down, so that, so just to give a quick example of, normally, like for example, if you were going to engrave this logo here and rotate the table at 90 degrees, I'd be using a ball nose here, and it's, at least for me, it's not ideal to use a small ball nose right on the tip of it, so I'd like to kick the table over a certain number of degrees. So I guess common practice is really just to create a sketch if you wanted to use a different angle here. And for example, I created a sketch here on this plane, and this logo here, I've used my tool orientation. I'll show you a side here. Let's go over here. I'm actually going to move this on this side so I can see it better. So you just pick your Z-axis. Normally, as I said, you'd pick this top one here. And you can see the Z-axis pointing at 90 degrees here. But if you wanted to use the side of the corner of the ball nose, that's the sketch I would pick. And then just press OK here. What's going on here? It's just going to process. My laptop's not the fastest. And that puts the kind of tool at an angle. The problem with that is if you have a part that requires you to draw a lot of sketches, I find it takes quite a bit of time. So my kind of tip that I've kind of done is I've created this almost star globe, and I've used it quite a bit, and all it really is a bunch of different sketches here on different planes, and I'm just going to turn them all on here. And it's just positioned in lines in almost most directions that you need. So you can go ahead and choose the one that you need. And I'll zip down here and pick, let's turn on the front one here.
Is that a linked part that you inserted?
I'm sorry?
Is that a linked part that you inserted?
Yeah, exactly. Yeah, I keep it, I pretty much, where did I go here? Let's go back here. So I've pretty much created this one model, and that's what makes it quick for me. I just import it right inside, throw it kind of, it doesn't necessarily be in the middle of your part. I just kind of put it anywhere and bring it in, and I just find it makes it extremely quick for me to pick an angle. So for this, if I simulate this one here, you'll see I picked, I believe it was this angle here, and the tool holder ends up crashing into the part here. So it's really quick just to be able to edit here, and again, just pick the next sketch geometry down, say this one here, or let's try that one there. And then the tool rotates kind of away from the face. So that's, I don't know, that's kind of my little tip that I've used quite a bit. I had a very similar option here for doing these radiuses on the back side here. I'm not going to show too much of that because after I showed Lawrence that, he's going to show some neat 5-axis simultaneous work on the back of that part. So I will head back to, yes? Not really, as long as it's not like directly down from me. 15 degrees is even better. It also depends on the size of the tool that you're using. Yeah, as long as you're not kind of directly down. I mean, you do a lot of small tooling, right?
Yeah, 15 degrees is like
Yeah, exactly. That's kind of the big thing that I use. On a small tool like that, I don't know, what do you think? 5 degrees? It also comes down to your clearance and stuff, right? Like if, for example, if you're trying to go on the back of that wall there as well. Yeah. I'm just going to show a couple examples. These are strictly 3+2 examples of parts that I've done in the past. This is actually one of the first parts that I think I did about 2 or 3 months after I got the machine. I'm actually pretty good friends with the Sandvik sales rep in Western Canada, and there's a local aerospace company that uses a lot of their face mills, and this one they specifically wanted, but they wanted it with through coolant capabilities, which Sandvik doesn't do. And if you want to order it from Sandvik with through coolant, I believe the wait time is 6 to 8 months, and they needed to do it for a job right away. So they had a few different face mills. The only problem is Sandvik doesn't give you full 3D models for them, so I had to model it up myself, and then I pretty much created the through coolant holes in all of them. I had to seal the top as well and put an O-ring so when the coolant comes through it would come out of the hole. So I mean it's a fairly simple part, but if you were trying to do that on a 3-axis, I think the time it would take to jig it up and then take it out every single time and rotate it would take quite a bit of time. So again, it's nothing crazy complex, but for me it was just the time savings of kind of doing it all in one setup. This is the job that I did for Boeing. There was quite a bit of these plastic parts that's used on their wing spars. These clamps come together and they inject like a polyurethane through those holes that compress on it, and then these clamps come off. Unfortunately, I can't show too much of the part, but there is quite a bit of surfacing on the top and on the back side, and there was about 40 parts and every single part was different, so I didn't feel like doing work holding for every single one. So this is almost a kind of a one and done part. Those tabs were created using the tab function in Fusion. When I cut off, the back side wasn't important, so I was able just to clip it off and then use some sandpaper to kind of finish off the back side. Again, a fairly simple kind of work holding strategy, but for a fairly complex part that made it pretty easy for me. This was some aerospace panels I did, which can be done easily on a 3-axis machine. You can kind of see there is a chamfer part here, and then this is the part flipped over, and then the inside was chamfered. It made it easy. I didn't have to surface those in. Actually, a nice thing is when you're doing deep pockets like this and it fills up with coolant, you can tilt your table and get the coolant out, which is actually something that's quite nice to be able to do. Even just getting all the chips out if you wanted to, you know, for finishing the part off. So these were actually for a Sikorsky S76 instrument panel, and these are the lower panels. That's the finished part there. The bigger main panel was done on my VF7. That was about a 15-hour runtime on that slow machine, and there was a bit of surfacing on the angle on the far part right over here. I think I don't have it in my slide, but this is what my customer sent me, and that's the finished part there. So there's the two lower panels are down here, and then the main panel up there, which is kind of neat. So again, you know, going back to the small parts, they're nothing absolutely crazy, but just not having to surface, you know, that chamfered wall saved me quite a bit of time just taking an end mill to finish that off. And the work holding on that part was pretty much just a sub table that I made, and then I did all the fixturing primarily with bolts and some aluminum clamps to hold it for the second operation. So yeah, that's that part there. And then these are some large molds that I made for fuel cell industry. They were being done in another shop, and then they changed the models for them. And then the customer came to me, I believe the second, it started with a fairly large slab there, which is dovetailed, if you're wondering how it's held. And then usually I think it would be about 5 to 8 setups to do, not that part, but there's two different, there's the bottom and the top part of the mold, and you can kind of see on on the one mold, there's quite a bit of fixturing around the side, and you can kind of see all the toolpaths around the side of it. There's even chamfers located on these clamps on the side that if you were to put on a 3-axis machine and hold it up, you'd surface them in. I was able to obviously tilt to the right side. Let me pull this up here. This is just to give you an example of how quick to do some of the chamfers were on all the sides. And this is, I'm running real time here. So again, trying to, I think doing these parts, again, I didn't do a big quantity of these. There were about 6 of them each. I think the total runtime on them was anywhere from around 2.5 to 3.5 hours to complete it. But once it was programmed, it was nice to be able to set it up and then go home and take a nap and then go back to work again. So, and then this last part, I don't know how many of you follow me on Instagram. This is a winglet that I had to design for unmanned aerial drones. I actually got one of the parts here. I'll pass it around. Just be aware it is quite sharp on the back side here. It finishes off at around 4th thou, so it's got a sharp edge, so please don't cut yourself, John. And this was quite an interesting part. In the video I posted on Instagram, I do show some 5-axis simultaneous toolpaths, but for that part, there was actually, it was done completely in 3+2. It was quite a bit of a tricky, at least for me, figuring out the work holding for it. It was done out of a solid block. I had to eventually break the part off, and you'll see it's quite a surface part. So what I ended up doing was I left a bit of the material on this side left here, over here. These were 2 threaded holes that were in the part. But this side here was actually curved, and the back side was flat. So I ended up just cutting a piece of aluminum here on the back side that I bolted onto the part. So when I machined the back side to fit off here, it was still supported from the back side. And so that side was, in a sense, completely machined off, but it was still supported. And then I machined the last part of the tip of the wing off. So again, a fairly kind of complex. Have all of you kind of seen the video on Instagram, or probably not, or maybe some of you have or not. Yeah, it was kind of an interesting little part. So there was left and right. This is not how they manufacture the part at all. It was primarily just designed for them to put into a wind tunnel test. And then I'm not exactly sure how they do the final manufacturing for the part. That's stuff the Army doesn't usually want to tell you. And that's a bit for me. Phil, you want to go?
Yeah.
So we'll bring your stuff up here.
I don't know how this works.
Press it down to continue. Yeah.
Oh, fancy.
There you are.
Yeah, so I'm just going to talk about some of the work holding I use for 5-axis stuff. I'll just start with just basic things. I started off with vices, centering vices, standard chucks, fixture plates, and clamps, and then I'll go into a little bit more. This is just simple lathe chuck. Everyone's got one, collecting dust in the corner of your shop that someone probably crashed on a lathe. So I use them for mills. Great, simple. Next, just a standard cart vise. Yeah. This is actually a part I designed, and I didn't actually realize how big it was until I ordered the material, and then I realized how small my machine was. And if you're wondering, the corners, when it rotates, do clear the probe by 50 thou. So I lost a couple years of my life on this one. But you can see, you can throw, if this even works. How do you need permission to view these? Ooh.
You gotta look that way.
Huh? Oh, yeah.
Oh, you know why you didn't share your, because you logged into
The material was 6061 aluminum. It was 24 inches by 12 inches by, I think, 5 inches thick. How on earth do I do?
You did not share with me.
What?
Yeah.
How do I share it with you?
not sure what you've done here.
I've never used PowerPoint or Google Slides before, so. Oh.
You know what? Unless you're going to have to give me access from your account.
Yeah, whatever. Figure it out.
Let me move it over.
Okay, well, I'll come back to videos, unless. Oh, no.
No, that's
oh,
fine.
Oh, jeez.
Why don't you come back to your videos after?
Yeah, I'll figure everything else out, and then we'll come back to the fun stuff. And then there's just standard Mighty Byte fixture plates, pretty standard 3-axis stuff, but if you have a 5-axis, why not just rotate that 4 or 5 times around like a tube stone, and then just make a small one you can hold in a vise. So this is just fun, creative stuff I like to do. And that way, yeah, you can get all the way around it, do your 5-axis work, and it looks really cool. And then this is just your basic clamps. We made a wheel, this is all very basic stuff, but you gotta get stuff done.
Do you guys make billet cases?
No, oh. I've wanted to, but there's not a real market for old. Yeah, we're just opening it up for a bigger bore. And then there's dovetail stuff, classic 5-axis work holding. You got dovetail vices, the little fixtures, and then multi-part fixtures that I love to do. So this was actually one of the first things I ever ran on a 5-axis. And this just shows kind of the power of dovetails. This is a rather big piece. That's 21 inches long. And we held on to, I think, a 1-inch dovetail, 80 thou thick, and did the whole thing all the way around. And it's no chatter anywhere, which was mind-blowing to me. And there's another video we can't watch. But that's really cool. The video's really nice. If you follow me on Instagram, they're all there. And there's just another example of just a small dovetail fixture. It's just a 1/2-inch one from 5th Axis, but it shows you this is like I think a 6-inch wide piece, holding onto just a 1/2-inch dovetail, and it's the same. That's not chatter, so just so everyone knows. So you can do big pieces holding onto barely anything, and surprisingly good results. And there's another. Oh, hey, yeah. And it's just showing you can get, like, if you look around, you can get all sides. That's one I made. Oh, that's this contour of multi-axis tilting. I use it for everything because it looks cool. And then I can tell people that my parts are very expensive because they're hard to make, even though I don't need to use that toolpath. And this is, I don't know if people have seen on Instagram, this is a big one. Yeah, I like to make things complicated to keep myself entertained. So we want to try and make as many of these pegs as possible, but I have to get all 5 sides on this design. For some reason, I designed it that way. So we have to use the whole angle or a whole travel of the machine from 0 to 110 degrees. So I had to design just a little fixture or a little plate that could hold all my dovetail fixtures so I can actually get around everywhere, and they're spaced out enough I can get tools through. Oh, it's just another example. You can do multiple parts on 5-axis and still get all the way around. And they're same thing, different style. And I got 4 pieces, and I can still reach 5 sides.
So you made your risers yourself, correct?
I did. I made risers myself.
How do you decide on the angle to put your dovetails?
So the angles I put the dovetails on a couple of those. If I go back, that was just because I thought that angle looked cool. On this one is because I actually had to get to all these odd angles. So I had to, because I can only go from 0 to 110, I had to angle these just just right. So at 110 degrees, I can finally hit my final side.
So it's not being familiar with much any of the programming stuff. You're able to do all that on-screen dry run, kind of like what you've shown us. You
Yeah.
can see obvious conflicts, just run through a process in which will tell you there's conflicts.
Yeah, you can. So in Fusion, I model up everything, and I make the stock for all these, and then I just component pattern my my cam, and then I run that through simulation, and I can see if it's going to hit anything. Though sometimes that's not true. I know. Oh, I think that's. I'm not sure, but I think that's only on the post side. Yeah, I don't think you can really. Yeah, I don't think until it actually makes the machine thing that we're talking about, or machine definition, you'll see that. Anyone else have?
How much do you steal or share these fixed access points between fixtures?
Oh, I have 5 of these and 4 or 5 fixtures, so I just constantly take them off, put them on a new one. Yeah, I'm not super rich. Otherwise, I'd have these everywhere, holding up my desks and chairs. And there's that. This gets me so excited. This is, I can't remember the guy's name on Instagram. I think it was CNC Machinist or something. But I've seen this, and I am trying to use any excuse in the book to make this. If you're making a part that had a feature on every side, with a little bit of work, if this was your soft jaws down here or your op 2 fixtures, you can reach 5 sides on 4 parts and then finish those 4 parts. So in one cycle, you're reaching every side of the part, and you get 4 complete parts. So I'm very excited about trying this. And here's my shameless plug for all the 5-axis stuff I have. Which I've been paid a lot to say. And then this stuff is so much fun. One and dones, tabs. I use it all the time on prototyping pieces that are within a certain size, which is scrap material I have. And you can make the whole piece in one operation, and I don't know why, that's just so cool. I just love it. So like this, these are just cool little tabs, some scrap material I had laying around, and I machined these down. I think those were 10 thou tabs. This is the first time I've ever tried it, and it works perfect. Machine the whole part, then at the very end you come and just cut your tabs, then break them off.
Are you hand finishing those after then, or?
These ones actually had an op 2 because it was a contoured on the bottom, so I had to flip those over. But parts like this was all done. This is just a prototype shift linkage we did. So you machine the whole piece, every side, all the 5-axis stuff. Then I came in, knocked this side out, then this side, and then just made my tabs so they were a couple thou. Cut it right off. And there's another video you can't watch.
When you're making the parts, how much, I guess the question is, do you design the parts, or does the client compile
No.
just on the work?
So everything that comes through my shop, I've personally designed. We don't take any outside work. It's just purely my products.
So you start from scratch, and that should go quite a bit back and forth until you basically on the
Yeah.
before you actually make it physical, right?
Well, I think that's how most companies would, but myself and my business partner are ideas men, and we like things in our hands right now. So we'll usually design something together for a couple hours and then spend the night machining it. And if we don't like it, then we'll do another rendition, but normally it comes out pretty good. Yeah. I know usually prototype pieces take a couple days, weeks. I try and do them in hours because I want to make this piece and then move on to the next piece. That's why I think we have 30 products we've made this last year. Not all of them have sold, but you know. There's another video you can't watch until I figure it out. And this, when I do figure it out, you'll see this is a pretty thin piece, and then we finished it off with a 4 thou tab. So it's just wobbling in the wind. And another video, this one when I figured out, it'll show you that we just push that part through and then immediately go on the bike that we're building. And I think that's all I got for. Pretty, yeah. If what we do is we move the bike into the machine and just push the part on.
Extending the question, design and the file. So when you design the part and you have the file, is that yours or is that the client's? Who owns the
Oh no, these are actually my products I sell. So I don't take outside work. This is my own little micro factory. I design everything, make it, and then I sell it.
Okay.
Yeah.
That's very different than what I was thinking.
Yeah.
I'm more a job shop.
Yeah, right.
Yeah, exactly. So for me, customers send me generally a drawing, and if I can get a 3D model from them, and then I send them a quote, and then if they go ahead, then I make it and send it out, and generally never see it again. So
Okay.
yeah,
Usually, when you don't see it again, it's fine.
that's a good thing. Yeah, it's true. When you don't see it again, it's good. Yeah,
Usually, if they send it back or you get a call about it, usually it's wrong. So
yeah.
if you can and you never hear anything, usually you say it's fine.
There are times where they make a mistake, and they want you to fix it after. So there's certain times when that does happen too. So.
So all right, into simultaneous,
Probably get my computer.
where
set up
most
for that.
people think this is complicated, and usually we buy software that is pretty damn expensive just to do small 5-axis stuff. I wanted to actually just show what we can do and what is in the future. So I'm going into Inventor HSM, because one of the features that will be released in Fusion 2 is Flow, which is in HSMWorks already, but it will be in Inventor HSM and Fusion as well. And
Next month?
I believe
next month?
in beta mode it's already going in there as well, I believe, but that's the same in Inventor now too. So it's being tested, but it should be in there quite soon if it all works out, if we find trouble.
He only shares the one video. So. Oh, I don't have the Mac one.
Flow, any estimate on when it should be in there?
Yeah.
In the next
I have to
update, yeah.
approve every one because it only came up with one. That's fine. We'll just do that right away. Oh, once he switches over.
Yeah, the one with the back.
All right, so what you'll see here now is the same part that Amish showed you before, which he just used for like 3+2 kind of stuff. And the radius here at the back that he was actually doing with is what he called a star globe to actually get a tool orientation on. And what I want to show you now is that since it's only in beta mode, we got to find it right here. But if we get into Flow, we just have a ball and mill here. And what we would do in this case, just select the same face that he actually machined in 3 axes. And pretty simple, we just tell it how many step overs we want, tell it to use multi-axis, and actually we should be able to just hit go and it would calculate a path for us. One thing we would run into now is that the tool would actually be touching the back face, which you probably have machined in another way already, which causes it to not look good. Let's see if it calculates quick enough for me to actually show this. Now the fun starts because it's not doing it, as usual. What?
Change turn to possible to show that if possible, it makes the toolpath a lot faster.
Yeah, fair point. But I didn't need it, tested it this morning. So what I actually do is now set the minimum tilt to 95 degrees. Because at 90 degrees, we should be touching the back face. And at 95 degrees tilt from the original tool orientation we got, which you see the Z-axis here, should actually allow us to machine the whole fillet, but be at an angle of at least 95 degrees. Of course, the machine can do 180 because your A-axis you would be milling straight through your own table. So what we'll fill in here is a 110. And let's see if we can get it to work that way. because I've got the same thing right here,
I think so.
which will actually just show you that in full 5-axis mode, it would go there and machine this radius. It shows that it will be colliding with the stock right now because I didn't pre-machine any stock right there, so it shows in red because it's actually moving into there. But you actually see the tool move its angle because in the beginning, flow always wants to cut like with the center of the tool. So now we're limiting it, and it will try and come as close as possible to that. But it will still machine the whole fillet. It will turn in case it's not possible. So what you actually see here now is just the tool moving around so it can machine the whole fillet. Then the next thing is you're going to say, like, why can't we do this around the whole part? And the answer, of course, is yes, we can, because that's the next thing we do. If we select all the faces that actually are around this part, like this, we still have the same setup, 95 degrees and 110, and we actually get a part, the toolpath that goes around the whole part. It's pretty easy to set up, and I mean, it feels complicated to do this full 5-axis, but actually it is like 1-2 minutes and you should be ready to go. Whereas if we do this 3+2, we got to do a whole lot of different operations to get around the whole part, which would actually take more time setting up than doing it just the 5-axis way. The same goes for like this back chamfer we've got right here. If you have this in the machine and you want to do it 3-axis, it's going to cost you to make quite a lot of operations to just go around the whole part. Whereas if you just take a swerve, which I'm going to set to contour pairs just for the sake of being quick in calculation, we select these 2 back lines, hit OK, and we already see this being calculated, being done. Hit simulate. Actually see it moving around. One of the issues that we do have now is that it would just touch exactly on the bottom edge that we selected, which means you'll probably see that in your part the moment you make this. So there's just a setting for extending your tool below that. This is the tool offset, which we'll put at 1 millimeter, for example. Since I'm from the other side of the world, I live in the metric world, so for me a millimeter is easy. As you can see, you just can fill it in. Even if your part is in inch, you can just fill in 1 millimeter and we'll calculate it for you. So one of the things that actually work great if you're working on someone else's parts that actually came in the wrong system. But now you can actually see, it's always wrong. See, it's actually cutting below, and it's a 1-minute job for actually cutting the whole chamfer 5-axis simultaneously, where it really would take a lot of time doing this in a 3-axis way. One thing you might actually run into the first time you try something like 5-axis is a toolpath you see like this, with all the different little movements in there. Keep in mind that usually when you have a flow, the system will make sure that the tool is not cutting into the model, but it doesn't really care about your holder. You can tell it to trim those passes that the holder will actually run into the part, but you can't tell it to move the holder away. In flow, at least, you cannot. You can, for example, in a 3D contour. That's what Phil uses most of the time, that it actually tilts away so it is clear of the holder. Flow doesn't do this, but if you look at
on this part, just for clarification, that hole is tapered out, so semi-portish for testing purposes.
So what you see here is that now it actually runs into the model, and it really is a bad toolpath. But with just one modification, and the modification I did here is, again, setting the maximum tilt on it's just a simple option. You tell it you cannot go beyond 25 degrees, or 50 would have worked in this case too. It cannot cut with the center, the bottom part of the tool, but it will cut with the side actually at the same point. So if you see the same path now, actually it looks like a pretty decent pass. and you can actually make this thing, whereas with 3+2, it will be very tricky to have a lot of setups or a lot of operations to actually cut around it. It almost looks like you could have done this with Swarf, but it seemed like the surface didn't actually allow for a decent sized tool to actually cut around it. So I'm just trying to show that pretty easily you can just machine it.
Question for you, where the toolpath, you see it, it's almost like making a linear move down that straight face at that sort of angle. With that noise in there, is it generating like many G1 line motions in that toolpath noise?
Yeah, like what line did you mean? I mean full five axis. We're always going to be in just line motions. There's not going to be circular motions anyway. But depending on the tolerance you use, you'll get more or less noise actually, of course, in your tool angle. The trick is with a ball end mill, you usually don't care as much about your tool angle because you're cutting with the bottom side or with the side of the tool, which we don't really care if the tool is a little off in angle because it's still the same kind of geometry you were cutting with. Actually, but when you're running a swarf operation, for example, with cutting with the side, there you really have to take care about your angle because if there's going to be noise, you'll really see that in your part. So for that, I would usually recommend going for a very tight tolerance in not only the operation, but also in the surface triangulation. I'm not sure if any of you joined Rob's class on this, but we spoke about it real quick, that if you change the surface triangulation, you can get rid of a lot of the noise. In this case, since for the swarf, I used just contour pairs. So I told it, like, this is the bottom contour you gotta follow, and this is the top one. So it doesn't really care about how the actual model looks anymore. It just looks at those two rails and machines those. So for that, we're not getting a lot of noise because it's two actual rails it will move about. Yeah, these yellow lines you see. Yeah, you can just turn them on and off here. The show axis. Those are actually the lines that the tool is angled at. I use it a lot for 5-axis just to have a feeling for how they're distributed, and if there's a lot of motion actually in the axis, because you'll see if there's a lot clustered, you'll see actually that there is a lot of motion. And for this, like here on the straight, you know there isn't going to be that much. So if there is something there, you instantly know something's going wrong in the calculation. I've got noise or I've got any issues there.
Is there a spiral to go down there if you wanted instead of make
For example, if you would take a swarf, you could, here we've got like different modes. You could just say spiral from top, and let's see what this does in this case. I haven't got a feel for much of the inch length, so to me it's too, huh? All right. Yeah, it should be a little bit more, 25.4, something like that. So actually, you've got a motion like that should actually not cut in some kind of a spiral with the side of the tool in this case. You could also have a swarf and give an angle offset, so you're not totally cutting with the side, but in the end you are more surfacing again, whereas with a swarf, usually you try to actually be cutting with the side of the tool and have as much length to finish in one go, but actually you could just do like this kind of spiral motion downwards.
tilt off the side?
Yeah, with the swarf you could also just tilt it off the side if you wanted to. There's this, here is the sideways tilt version, and you could just give it an angle you want it off of the actual face you selected or the two guide rails.
Quick question. Is this for this part the fastest strategy? Because to me it looks like you could just do a Z ramp down this one and do the
Yeah,
it's not straight down, it's tapered out, so yeah.
if you see like this, we cannot see the actual. You can see like this that.
I just didn't see that it was tapered out.
Yeah, but if you look at it like this, there.
Quick point, the way it goes, if you use a side trim, if you use a lolling block cutter, the 3D contour will measure the geometry.
If you
Yeah.
go all cut it right, yeah.
Yeah, so if you actually do, calculation-wise, this always takes some time because actually the calculation of the toolpath will be done multi-core, but actually the tilting is, I believe, as well. But the linking usually is done with just a single core operation, and that's fine. But for the tilting operations, there can be very tricky linking moves, and it's got to try. So it could take some time. Usually with the full 5-axis operations, you get a good toolpath quick. If it takes a long time, usually something is wrong or you'll see noise somewhere. But with the 3D operations and tilting, if it's undercutting, you might actually be waiting for a pretty long time. But if you've got a lollipop, it will still see that it can go there in a 3-axis view. And then in the tilting, you tell it to stay off of it more than you used to, and you could even use a normal ball end mill if you wanted to, which I've got some videos on my Instagram, like doing exactly that.
Is that it? I can throw some videos on if you want to see.
Custom profile tools.
Not yet, sadly enough, but it's one of those things that I would like. On the other hand, like 90% of the stuff, at least I do, I can use what we've got. And from what I know, most people are not really into 5-axis simultaneously anyway. We see it in the Netherlands quite a lot because we're very, very expensive in labor. So we need to do crazy stuff to actually have a chance of surviving as a job shop. Because otherwise it's much easier to just outsource it to Germany, where they've got like machine shops on every corner of every street. But so for us, you see like maybe 10-15% actually using it on a daily basis, whereas in the rest of the world, a lot of people actually buy a 5-axis machine and the simultaneous option and use it like once every month or once every year or not even ever touch it. So I would like firm tools tomorrow, but I know it's just such a small group of users that actually would do that, that I actually think it's going to be a long time before we're actually there.
I'm going to switch it back quickly for...
Yeah, fair point. Yeah, you got to wait a little till it changes it. Yep.
There we go. Presenting. Present.
No, I would just play it this way. Probably be easiest because it looks
Okay, now that all the boring stuff's out of the way, we can go back to me. Come on. Yes. So, yeah, you can throw these curved vices around pretty good. And so I measured to make sure that stock was not going to hit the trunnion or the probe. I didn't remember to make sure that wasn't going to hit the side. So the first time that whipped around, I thought I was going to have a heart attack, but it was fine. Not by much, though. Not once. Yeah. Blah, blah, blah. Yeah. All the fun stuff. And there's that was half the swing arm we made. Again, just full 5 on a pretty long, wide piece, holding on to almost nothing. There was no real reason I needed that toolpath other than I was working 18 hours a day and I wanted to be entertained. And our Netflix wasn't hooked up. Yeah. Watch that one. Skip these boring things. And there's just a little tabbed part, not quite a one and done. I machined the chamfers on both sides, but I left the piece about 10 thou bigger, so I could put it on a fixture, clamp on the inside, and then finish the outside. And here's that 4 thou thick tab we did on this. That's right off the machine, just very loose. I think I measure it here at some point. Yeah, I had to make a little model to go around, so I knew exactly where I was going to cut. And there it was on the bike. And there was another one. Just a little guy, I could poke it out. That's so nice. And then straight from that onto the bike or onto the part we were making. And it was done, one op. And I think that's all the videos I have. Hold for applause, I think that's what we did.
We have two minutes, I guess. Any questions for anyone or for Lauren especially?
Do any of you guys have any experience with any other 5-axis programs like PowerMill or any others, and how would you? Okay.
I've opened I've opened up PowerMill to take a quick peek at it, but I haven't given it enough time. Most of the work that I'm doing that I kind of showed, it's primarily 3+2. I've seen demos of PowerMill, and there's options in there that I think it's got machine dynamic control, which is pretty much a faster way of like that star wheel that I've done, just to be able to tilt your tool. I'd love if that came to Fusion now, but yeah, I haven't used it. I haven't used it a whole lot myself. Lawrence, I don't know if you played around.
No, I've kind of looked at it, and then was like, I can do like anything I want with this. I'm not saying it's faster to do it this way, but I've kind of gotten used to it. So for me, a lot of the stuff I can actually do, and usually when I take the time, the code that comes out is pretty decent. So not much complaining there, but I guess indeed Rob has used like anything on earth by now to actually know what's going on.
Yeah.
A whole lot of stuff with a lot more power, but that power really gets leveraged well, a pretty small percentage. So it really just depends on what you're doing.
I have a full 5-axis SSCadCam, but I don't want to talk about it. That dongle is kind of just supporting the wobble of my desk right now. So.
You guys are using 360 for that most of the time?
I'm strictly Fusion 360 myself, 100%. Yeah, Lawrence, you kind of use everything because a variety of different machines you have, right?
Yeah, for me it started like I already used HSMWorks before it was bought by Autodesk. So an HSMWorks is the plugin for SolidWorks. And then the package came out, they actually got like Inventor with the HSM combined for the same price, which meant that the moment we started adding more seats, especially for turning, we started to move over to the Inventor HSM. There's a couple of small things that might not actually be in Inventor HSM for 5-axis, like full 5-axis stuff. So that's why I personally use HSMWorks a lot still. But especially the last couple of updates that came along moved Inventor HSM and Fusion 360, which are usually quite equal in features, to almost to the same level. We need some small things, and then it should be quite the same for Inventor HSM as HSMWorks to do this stuff.
You guys mind if I jump in and talk about PowerMill? So
Yeah.
I just joined Autodesk, but I used to use other CAM softwares. PowerMill was the first thing that I latched on to as soon as I knew some 5-axis work. PowerMill is essentially you find the right fit for the right tool. So Fusion has its place. There's a great market. It fits a lot of what most people do. You're getting into the realm of full 5-axis, and there's very specific parts that you're going after. That's where PowerMill fits best. Yeah. The same as like if you're going where you're going to go to another solution that Autodesk has, which is part maker, and that would be the fit for you. So it really is what you're doing, essentially.
Exactly. If you're getting like Blisks or something, there's specific software that you'd be getting to do those in.
Well, we offer a full range of everything that's on.
Yeah, but what I try and explain to people, like, if your parts are like quite simple still, I try to explain to them, like, I'd rather have 90% of my parts programmed quicker and the 10% move on way longer than I would do in, for example, Power Mill. But if you've got really complicated parts all the time, then you're winning buying something like Power Mill versus the HSM software.
Specifically the Power Mill, from a product management perspective, you're always making compromises and trade-offs. On the Power Mill side, the compromises, we have to have the power. And that, on the flip side, on the HSM side, the compromises, we want to make it accessible and easy to use, and sometimes that sacrifices power, and conversely, adding power sacrifices ease of use. And there's an overlap in what we perceive to be being able to make the same parts, but to Lauren's point, his preference is to be able to have everything happen quickly, and then you sacrifice some power. In some cases, you need the power, and so you're going to sacrifice some ease of use.
It's always going to be like that. Yeah.
If you're new to playing with sci-fi axis for fun and just trying to get your feet wet, would you recommend focusing on a sport or 3D contour or one of those specific toolpaths?
Personally, I would say on one side, Swarf is the easiest to start with if you're actually just chamfering off your part. But if you actually want to do like a full face, actually the full depth of your cutter and actually make a really nice surface, you usually run into other stuff that's not necessarily part of the software, but the rigidity of your machine. Like, I mean, there's a lot of other stuff that you actually run into. So that really needs more of a feel for it. So you need to do it a lot, but actually just doing some contouring work with something like Flow or the 3D contour with multi-axis tilting actually is pretty easy, and you don't really get negative effects from using it, especially since the angles don't really matter that much. So even if you put your machine on, go as fast as you can, and not being real accurate, it still produces a pretty decent surface finish. So with that, I mean, will be a good place to start.
The one thing I noticed with contour or multi-axis contour, or tilting, one of those. If you're out or posting in vector, it will not make the part the same as simulation will. So your machine is going to be spinning around doing crazy things you're not expecting, so it can be a little daunting. Yeah, 'cause with vector, normally you have like ABC kind of things. You're telling the tool to go, or the trunnion or whatever, to move to that angle while you're cutting. Well, with vectors, it's all based off the angle of the tool into the piece. I think that's right. So it's like a whole different kind of system. So I can run one vector program on my Herco and take the same program and run it on your Haas, and it'll still run, but they won't do it if you do ABC because it's different things. But yeah, your machine will be spinning around, and it can be pretty scary.
The difference is the post looks at the machine configuration you give it, and then it will actually look at what the axis angles need to be, or it will just give the angle related to what your original coordinate system was like. So that's the difference or it tells the machine exactly like go A-axis to this angle, or will tell it go to this angle in space, and however you do it, it's up to you.
Yeah.
Yeah, but the trick is that usually with a machine, there's two ways to get to this same orientation, and it's especially tricky when you're moving on one side and the control thinks, well, I'm going to the exact other option for the next pass. So with that, I usually say just make it the machine angles. It's much easier to understand if you're actually behind the machine, because you just... No, usually most posts, if you set up the machine configuration in the post, it will always output in angles. And if you forget about setting up the machine configuration, it's like, I've got no clue on what your machine's like, so we'll try and output the vectors, at least for the Heidenheim post, and one more I get, and the Herco one. Yeah.
A quick thing, guys. Very big congratulations and thank you. The guy just told me we're the last class in the building. You Good job being able to stick around. Thank you for sticking around.
Yeah, thank you.